Now, let's dig in the foundations of blockchain. Like with traditional databases, blockchain databases are pillars that support the registration of ownership and the economic activity that flows through the different blockchain databases. Let's have a first high-level overview of its infrastructure, its content creation, and its security. First, the blockchain infrastructure. The blockchain infrastructure is quite simple. It is an open peer-to-peer network of computers, or otherwise stated, a collective of computers that are connected to each other over the internet in a freely joinable global network. And each computer has an independent instance of the blockchain database. Now, all the participating computers communicate constantly with each other in order to share the latest available information. This type of network communication is called the Gossip Communication Protocol, by which computers share their latest information with their network neighbors. By having every computer doing that, new information or new transactions ripple rapidly over the entire network. Let's have a look at the content creation of a blockchain. We just saw that the Gossip Communication Protocol allows for new transactions to ripple rapidly over the entire network. But sharing the latest information with every computer doesn't result in each computer having the same version of the database. It could be that individual computers order transactions differently in time, or miss some transactions, or consider invalid transactions as being valid. So, how does the system manage to have independent but identical instances of the database on each computer? Now, that's realized by having all the computers participate in the creation of a consensus, which allows to reach an agreement on one single objective truth on transactions that each computer then adds to the individual independent instance of the database. Let's rephrase. The consensus process allows for all the participating computers to agree on one single version of the transaction history and write that same version in each individual instance of the blockchain database. Once a consensus has been reached and added to all these independent individual instances of the database, then you also need a way to secure that content against hackers that seek to change and replace the content with false content. Well, it's cryptographic digital fingerprinting and a game-theoretic element that protect the blockchain database and all its individual instances. By having a cryptographic digital fingerprint on the entire content of the database, you have an anchor for verification of the database integrity. We'll explain in more detail in the next section how that works, but we can already say that a correct fingerprint is created through proof of work, also known as mining, and starts with a certain number of zeros. A change in the content of the database results in a fingerprint that doesn't have the required number of zeros at the start, which serves as an alert for an attack on the content of the database. The game-theoretic element that secures the blockchain database against hacking goes as follows. The extreme difficulty to crack the digital fingerprint on the database requires enormous monetary investments. Using that investment for honest mining yields a return on investment. Using that investment to crack the digital fingerprint, which nevertheless will be detected by the network, destroys the value of the system and the value of the hacker's own wealth. See you in the next video.